I want to talk about one of your portfolio companies, which is PsiQuantum. And recently, Quantum had some breakthroughs from Google, but I think you invested in, way early before anything about quantum was in the narrative.
You're doing, everybody was doing software, right? Like there was nothing else, right? Like, software was eating the world. We had the clean tech bust 2010, 2011. So nobody wants to touch anything that's like remotely hard technology part of it. Most of the big VC firms were like basically retiring out their hard tech or their hardware VCs. So it was very clear that if you talk to entrepreneurs in like core technology, new technology, new invention, they have like a very few VCs to go talk to, even in Silicon Valley, right? So we felt that there's like a missing gap, and then that was my DNA in terms of evaluating new technologies. That was what like interested me in technology to start off with. So we felt there's a gap, especially in India. The navigation is by more around you will find this particular place, turn left on that. It's never about okay, turn left on the street. It's to turn left on this point of interest, and that point of interest again will have six different names. And it's a much harder data problem. That data is going to be very, very valuable. So we invested in them like 2009. So it's they went public 2 3 years ago now. Even today, there's nobody who can come match up with the quality of data that they have built.
Welcome to Startup Project. My guest today is Karti. He was previously managing director and vice president at Qualcomm Ventures. He led investments in companies like Waze, Validity, MapMyIndia. He currently runs MFA Partners, where he invests in deep tech companies across AI, robotics, and quantum computing. In this conversation, we'll talk about how he became a full-time investor, his career in investing, and investing experiences in deep tech and corporate venture capital. What does it take to become a great venture capital investor? And what does it take to start and run your own VC fund? And a lot more. If this is the first time you're listening to Startup Project, don't forget to subscribe to us wherever you listen to the podcast because it helps us reach more audience. Karthi, welcome to the show.
Yeah, thanks, Nataraj. Glad to be here.
So I guess a good place to start is, how did you come into venture investing as a career?
I don't think it was a plan at all. In fact, some of the people that knew me from very young age, if they hadn't met me for 20 years, they would have been surprised that I'm an investor or even a business person. I think like when I was younger, I was going to be do a PhD and then go develop new technologies. That's what the plan was, and that's what I pursued for the first maybe 10 years of my career, building new things, semiconductor stuff, wireless communication, and new stuff. I don't know. I think it's circumstances where I would get getting pulled up. We're going in front of customers, leading people. So I basically learned that maybe more than my technical capability to build things, maybe I have other skills. So, which is what led to me to do a MBA. And I had a very clear thought that I want to come back to technology. I was not going to do anything else, but maybe more as a business person. I spent a summer doing venture capital, and until then I was a startup guy, just doing startup stuff. And then suddenly I'm evaluating startups. That was, a lot more interesting, where I can look at several variety of startups. Even then, I hesitantly just jumped in, saying that okay, maybe I'll try this for a couple of years. And I don't think there was any planned stuff to get into venture capital. And it's also, you've had to rewind it back. Will I just go do venture capital? I don't know. I might have just done the product management and go be an operator. So I don't think it's just a very well, defined pathway or anything like that. It's, I still go back and forth thinking about, okay, if I had to just rewind it, would I have taken that? I had two job offers in product management in like wireless communication at the time. Anyway,
How did that
I
happen?
keep wondering whether it was right there or not.
So what is your first job in venture?
In venture. So the first job in venture, I spent time at JK&B Capital in Chicago. So that's where I was doing my business school. And in venture, unlike other areas, you have to basically go fight for your job. It's not like, yeah, they're just looking for some smart people. So I basically reached out to them saying that, hey, look, I've done a lot of stuff in semiconductor stuff and wireless communication. And it seems like you guys are starting to look at that, and then I can add all these things. And then I basically said, all the stuff that I can look at, reconfigurable semiconductor stuff, new architectures and whatnot. So they like that. So, okay, all right, that's an area that they're spending time on. That's an area that they didn't have any expertise or not have deep expertise. So they felt that, okay, you could come and do that. So I joined basically to just look at all this stuff, new electronic stuff, new microelectronics, new semiconductors type of thing. So I was basically doing, sector analysis, reviewing companies in those areas and whatnot. Right? So I think that the one key thing in venture capital is that compared to others, like is that you have to basically define a job opportunity, job description, telling them that you need this and this is what I can come and help you out. Right? Even as an associate, even as the entry level person. Whereas in every other job, you say, okay, all right, I'm a smart guy, I can do software. Okay, where do you need software engineer? Where do you need a hardware engineer? Where do you need like an analyst? In venture, it's not that, right? You got to basically go fill a hole, or you got to basically create an opportunity and then say, I can go fill that opportunity.
One quick second. I think there's a bit of a lag. Are you
Right.
experiencing any lag?
Yeah, you went on like a buffer or freezing for a while.
If you have lots
I'm
of
not yeah, yeah.
tabs open up, like close Chrome tabs, that takes a lot of memory.
Okay. Don't have a lot, but let me close off. How was that? Just one now. This
Yeah,
is the only
if it
tab open.
buffers, you can just wait a couple of seconds, and the words will flow in. So that's
Yeah,
what
yeah,
I do on my side.
yeah.
Um, all right. So once you joined the firm, you started understanding, venture capital. What were some of the early deals that you worked on?
So one of the early ones was like using wireless communication for tracking stuff. This was like in 2005. This is like 20 years ago now. So they're creating a proprietary wireless communication stack for tracking objects or tracking like assets going around across the country and things like that. You got to think about this is a day. This was early days of 3G, and then we are at 5G, but it's the early days of 3G. Most of the data communication was like pretty low key, and yeah, and anyway, so we think of it like what the tags that Apple tags, but it's kind of a early incarnation of that, but more for like big assets. And it was interesting because I had wireless background and I had some microelectronics background as well. So we didn't end up investing, but it was interesting to understand, how there are problem statements that need to be solved using technology. And the key learning there was that you always try to solve a business problem and then you solve it through underlying technology, but you have to be aware of how underlying technology is getting commoditized so fast. So one of the early ones that Qualcomm I evaluated was around navigation app, and I think this is like 20 years ago. People don't realize that this is before Google Maps. You pay $10 a month to rise an app, which will give you a phone-based turn-by-turn navigation stuff, right? So it was a business need because you're driving and you don't want to buy a separate navigation device, so you want to use your phone. So for turn returns of $10 a month, it was a good business opportunity. So it was actually some of the companies are doing good revenues, but the underlying technology was getting commoditized. Right? The people are basically MapQuest was saying, "Oh, I can do it for $4 a month," and then Google said, "You know what? It's free." So suddenly, these companies' business model just went away in one day. So it was good to understand both the business problem, but also what the underlying technologies. And that's the thing about deep tech or new technologies. Now we define it as deep tech, but new technologies, they get commoditized very quickly as well. Like whatever I built 25 years ago as a startup, today is like 5 cents chip, right? Like nobody cares, right? It's like a commodity, right? So understanding the technology curve, technology progress is extremely important to figure out, which is going to last longer and which is going to just go up in flames.
Is there any pattern that you've identified in terms of figuring out if some new technology is getting commoditized, then should we invest or not? Like how do you make that decision?
It's a lot of I would say a lot of heuristics, right? Like you kind of try to see what is the path of commoditization here, and then who could actually retain still value. So one of the things, like in this whole stack, when we looked at this turn-by-turn navigation at the time, is that yes, the turn-by-turn navigation part of it was $10. It went to zero when Google came out, but we felt the underlying data, the actual map data, the actual data of where all the points of interest are and stuff like that, that is not easy for anybody to just go build it, right? Like, so at that time, Navcheck and Teleatlas were spending like hundreds of millions of dollars, maybe not quite that much, maybe 50 to $100 million every year to just make sure they have the updated stuff, right? So that I didn't ever feel that that's just going to get commoditized just based on technology down to all the way to zero. That's still going to have value. So that's what led to actually two investments. One in US called Waze, Israel and US called Waze, and the other one is in India called MapMyIndia. So in some sense, you got to figure out what could get commoditized and what could not. So for example, would NVIDIA's GPU could get commoditized down to nothing? I think there are a lot more barriers there, right? First of all, to get to that level of performance, but more importantly, they have built the stack on top, which is the middleware, the software, application layer. So they have basically created a moat around everybody using the CUDA, everybody using their software middleware to build their application. They'll be able to preserve quite a bit of that, right? So you look at all possible stuff. Do they have any other protection here, or are they just in the whim of the technology curve? If it's just that, they're probably going to get commoditized. But there are cases where there are physical needs, there are things that have regulatory stuff and things like that, where there's going to be enough of resistance to completely get commoditized, and then you kind of look through a combination of that, right? So yeah.
So what was the lens behind investing in India? What was the thesis there?
Can you repeat that? I think you broke for a little bit. The lens behind.
Yeah. What was your lens behind investing in MapMyIndia?
So, like I said, we looked at this whole stack of navigation, um, turn-by-turn navigation, or GPS or location-based services in broader terms, and we felt that the biggest value there is in the underlying data, POI, points of interest data. That's the one that's not easy to get it, and then that's the one that requires a lot more time. And Waze was doing it in a different way. They are basically doing it in a sourced way. They had like the interesting tricks. MapMind is more traditional way, but they're going after the market, which is very, very, very unstructured, right? Like whereas in the US, it's very structured. Most of the Western markets, we went through this in the 1900s, maybe mid 1900s to standardize the addresses, to standardize things on a grid and stuff like that. Even Europe, Western Europe, even though they're older civilizations, but a lot of effort was made to standardize that. So it was easier to maybe go collect data in some sense, but India still is like completely, unstructured. And then more importantly, uh, there was no one standard norm. People, just to give a quick context, when a parcel of land is, assigned or divided, there is a plot number or a parcel number. And then there is the next step, which is, okay, I'm now going to do something, which is like, so there is a numbering and then maybe a road. And then finally, when everything is built up, there is an official street name assigned and stuff like that. So you have like at least three different versions of things, but most of the times like five or six versions of it, and then different people use different ones. So there's in the same street, same place, you'll have one which is based on the parcel number or land number, and then some in the early street number, and then finally something which is the supposedly the standard one. And there is no horizontal vertical lines and whatnot, so which basically means everything like from not just the mapping these data, but also how do you route this data is like very, very unstructured. And then people who have done anything in Asia, especially in India, the navigation is by more around, you will find this particular place, turn left on that. It's never about, okay, turn left on the street. It's to turn left on this point of interest. And that point of interest again will have six different names. And it's a much harder data problem. So which is why we felt that that data is going to be very, very valuable. So we invested in them like 2009. So they went public 3 years ago now. Even today, there's nobody who can come match up with the quality of data that they have learned. So that was the thesis, that the quality of data for you to get in a country like India, unstructured data like Indian addresses, it's going to be very hard, and it has proven.
And even I think a couple of years back, Google was still trying to like introduce a standard format of creating addresses in India, which I think is a whole another. Talk about the differences in incentives. Like when you work at a fund at an early stage, in some firms you get some carry, some equity in the fund versus your salary. And in corporate venture firm, there's again the component of your W-2 salary plus some equity component. Talk to me about the nuances of those incentives. I think that's a little bit of under-talked part of this industry, is like, especially for people who want to think about coming into working in venture, who are in early stages of career, what should they maximize for here?
So early on, there's not as much difference actually. Because if you think about it, early on, you're learning to get your own network of entrepreneurs where you're trying to connect with them, where you build a relationship with them, and then figure out which are good investable startups. Curating that, figuring out your own way. What is a good startup to invest in, what is not, and what's something that maybe a good startup, but we need to probably wait a little bit for them to figure out, and then making sure when a round does happen, you get allocation to it. Those are all the first, when you start as in venture capital, those are the first things that you're focusing on, right? Frankly, there's not as much difference between a corporate venture versus a financial venture, because the early years you're learning the craft, you're learning to figure out how to get into these companies, and then figuring out, do you have your own expertise in terms of what you like, where you have the edge, and things like that. Right? Some of the bigger financial VC firms will have a brand in terms of attracting entrepreneurs. Corporates also have that, right? Corporates will have, like, the Qualcomm. So if you're anything to do with semiconductors or wireless communication or communication in general, Qualcomm is like a well-known name. So so to have somebody from Qualcomm validate your technology or validate the company, or a potential partner, is very interesting as well for the startup. So there is interest from that. Uh, so early on, it's actually, there's not as much difference. What I've seen is that at Qualcomm Ventures, especially, maybe it's not true for all corporate venture firms, but at Qualcomm Ventures, we were given reasonable autonomy to actually go chase investments, and then if you do end up making investments, we be on the board, or be responsible for the
But
investments.
do you also get
Whereas in many
equity compensation along with your W-2?
So on the compensation side, again, early on, it doesn't matter as much, right? Because if you're thinking about it, you get some carried interest plus bonuses plus salary in a financial VC firm. In a corporate firm, some of them are now instituting some carry, but let's say even if you didn't have carry, you probably had bonuses, stocks from the corporate, and salary. It was still okay. It was still the same, almost the same. There was not as much difference. Right? Where the difference comes in is in the later years, right? Where, okay, now you made these investments. One of them, like for example, Waze was a good outcome for us, for me, for Qualcomm. I don't think, if it had been similar in a financial VC firm, the compensation you would have got would have been different, right? So it starts to matter once you go like 5, 6 years in, because the investment takes 6, 7 years for it to get exits and things like that, right? So once you go 6, 7 years in, then that's when you start to see it. So the corporate VC, you want to think about it is that you live within a band. Your downside is protected, right? Like, whereas in a financial VC, maybe if you're not as good, you probably get cut very fast. Whereas maybe in a corporate, you have a little bit of strategic value and all those things. So in a corporate, your downside is maybe a little more limited, but your upside is capped, right? Like, you are not, you're never going to have this unlimited upside or large upside, right? So you live within a band, which is okay in the early part of your career, but later part of the career, it's not, right? So if you think about corporate VC as a career, early in the thing, a good corporate VC probably offers you almost the same amount of incentives, opportunity to learn, and things like that. But once you're 5, 6 years in, that's when you start to figure, man, I'm a good VC. I'm not seeing the same upside, right? So that's when you start to feel that, right? So to summarize, that would be the thing. Like, few years in, it starts to make a difference, especially if you believe you're a very good VC making very good investments.
But so you're saying the even though like even though you make good bets early on in the farm, your upside is also capped because of the way the compensation is structured.
You could get promoted. You could get like a bonus. There might be a salary around that, but you're still going to be along with the corporate norms of other people that are working in the company. So you cannot completely, so you get a 100x or 30x or a 50x outcome doesn't mean that you suddenly make like a couple of $1 million. Right? You still have to be within the corporate norm, right? So
Yeah. So you made a couple of interesting, bets, or was part of it, like Waze and MapMyIndia, and then you decided this wasn't enough compensation, and started your own firm. So what was that journey like, and how challenging was it to raise your first fund?
yeah, it was not the compensation alone. It just felt that you're. I became a corporate VP, and then you probably kind of feel that okay, this is probably where you're hitting the roof here, like in terms of where you go from there, both in terms of learning, in terms of all this, and then also in terms of hey, I'm making good bets, then I should be compensated accordingly, right? Um, I think like the transition to starting a firm um, probably was one of the hardest experience of my career that I had to go through. I've been an entrepreneur before that and things like that, and but this one, raising money from LPs is very different from raising money as a startup. So I think we went through quite a bit of thoughts around why am I doing this. I think the main reason I felt was that look, this was in 2017, 18. I was thinking to 2016, 17, 18 when I decided to leave. Software is ruling the roost, right? Like you're doing, everybody is doing software, right? Like there was nothing else, right? Like your software is eating the world. We had the clean tech bust 2010, 2011. So nobody wants to touch anything that's like remotely hard technology part of it. Most of the big VC firms were like basically retiring out their hard tech or their hardware VCs. So it was very clear that if you talk to entrepreneurs in like core technology, new invention, they have like a very few VCs to go talk to, even in Silicon Valley, right? So we felt that there's like a missing gap. And then that was my DNA in terms of evaluating new technologies. That was what interested me in technology to start off with. So there was we felt there's a gap, and that we could go fill it. Um, and then we felt that there's a new, we used to be selling technology to technology companies. That's what it used to be mostly. Other industries, other verticals typically adopt to technology very slowly, very late. But that was changing. We invested in a Qualcomm company called Cruise, which was doing autonomous vehicle, and GM bought for $1 billion very, very quickly, almost like a technology company buying a early startup. Um, so we could start to see that this vertical is now worrying that they're going to get disrupted. So that was the reason to start this firm. We felt that, first of all, deep tech companies don't get enough attention. And then there's like new opportunities of verticals adopting new technologies as well. So there's a big opportunity and a gap. So that was the thesis to start this thing. But the fundraising and then building the firm, suddenly you go from, okay, I'm part of Qualcomm. Even though Qualcomm didn't have as big a name in Silicon Valley circles when we started, but still, it's still a big company. Um, to going and basically building the entire stack. But the biggest thing was fundraising. That was the biggest thing because as a corporate, we said how to go fundraise. We investing out of the balance sheet. So there's a lot of learning there. And then when it comes to investing as an LP, it's really a trust-based thing, right? Like people are going to invest based on trust, which basically means you could raise money really from people that know you or at least know of you. You couldn't go beyond those circles, right? Or it takes much harder to go beyond the circles. So some people might have a big circle of this thing who have a lot of capital that they know you or know of you. Sometimes they don't. So if you're coming from a financial VC, sometimes you'll have enough of this relationship with the established allocators of capital, so it may be easier to raise capital. Whereas coming from a corporate, I had to go basically learn that from scratch, right? So learn that from scratch, go build that relationship, go build that network of folks that trust us and whatnot. So it was much slower, harder. So, but it's not a short term thing. Number one, number two, you don't do it for other things like, oh, I want to do it because that's what everybody does. I want to do it because that's a status symbol. If you do any of those reasons, you probably would have quit at some point. I think we felt that we thought this through. We felt that there is a need to do this for a very long term. So we were able to go through all the ups and downs, and then now we're investing out of our fund too. I don't think we're still arrived yet in terms of hey, fundraising is like a cruise control type of a thing, but it's been much better than how it was when we started.
So, are there any sort of one or two quick lessons that you can share or learnings that you would change on how you did your fund one first raising, like based on now that you've done, two rounds of this?
There's a statement that everybody has a plan until you get knocked in the face, right? So I don't know whether there is any plans that I could have done. In fact, we're all like very rational people. Like I'm an electrical engineer, so a lot more analysis and stuff like that. So I don't think I could have done any more analysis and stuff like that, right? I think the only thing I would have said is that there are so many people that I felt could have invested in the fund didn't end up investing. So separating people from their capital, even as an investment, right, is the hardest thing to do, right? So which basically means that yeah, we started off thinking that we're going to raise a bigger fund. Maybe we should have started off thinking that we're going to raise a very small fund, right? So maybe that's the only thing. That, okay, assume that everybody is who you potentially think could invest is not going to invest, and then maybe start off that way. But I don't think the end game would have been any different. We would have probably ended up being a similar sized fund and whatnot. Maybe we would have had less disappointments, less heartaches. But anyway,
Let's talk a little bit about, deep tech itself. I mean, now the term became pretty, common. I think that's to do with, some of these companies like Anduril and I think A16Z sort of pioneering something called American Dynamism. I think there's a lot of like a narrative. I think maybe SpaceX and NVIDIA sort of also, are, hard deep tech companies. And in my view, VC has always been for like really hard problems, like when first Intel was coming up on the scene, when government was actually Intel Q had that fund was investing in these ideas, which original internet and silicon chips. It was really to solve really hard, unknown, risky problems. And then I think we sort of went haywire in between, and then we started funding everything and call it everything as we see now. Um, so you, I think, probably found the right time where, as you said, was everyone was focused on software, and in a way, it's sort of like an easier problem. And as if we've solved all the hard problems and only these problems are left. I think that sort of happened in, I would say, in 2027 to 2020, where people were not looking at hard problems really closely. At least the narrative was not. Because there were always firms that were focused on such stuff, clearly. So right now, what do you think where the deep tech is and which areas you're interested in trying to find companies in?
yeah. So you're right. Like VCs used to fund hard problems, right? Like not necessarily R&D, science research stuff that labs used to do, but like when something is proven out and ready for, hey, now this could be now go built, but it's still hard. It's not like obvious that you don't have customers, you don't have obvious stuff, right? That's what it used to be. And then internet first started this. Now you have a lot of internet companies, right? Then mobile, and then the whole concept of elastic compute, virtualization started, the cloud compute as well. So you put all those three things come together. You have internet, you have mobile, you have the cloud compute. It all coincided with with two things as well. So one of the reasons why this happened, right? I used to think, like, why is this happening? Because this concept of deep tech stuff, right, or deep tech or core infrastructure, it's been there for the last 50, 60 years of our technology evolution, right? Like you come up with the microprocessors. Oh, now which initially we started this, personal computing era. Now you got a bunch of applications there, layer stuff, right? Then you started the basics of internet infrastructure, internet technologies. Oh, you start all these things, right? See, this is how the technologies work. You build the harder stuff, then you can build applications and utilities on top of it, and then the next generation of stuff happens and things like that. Right? So in that cycle, nothing has changed. We went through these things. Now the next one was robotics, automation, AI. So it has been moving in those things, right? So, but I think what happened was, um, you know, both the internet, mobile, and cloud compute, all of them now provided this era of cloud applications, internet applications, web mobile applications, and then it coincided with the time of like a hard landing of clean tech, where people were doing all sorts of crazy things just crash landed. And then the evolution or the emergence of China as a semiconductor hub. Silicon Valley was Silicon Valley. It used to do a bunch of semiconductor stuff, right? Like, hey, it's a video processor. It was an application chip for this and things like that. Those type of slightly easier to do, maybe not the hardest one type of a thing, just move to China. Just China would basically do all those things. You couldn't do like hey, I'm doing this microcontroller video application stuff. Doesn't have that deep an IP, but you still need to go build this. That used to be one of the biggest areas of venture investing, venture for funding. Went away because China just took it. China and Taiwan just took it. You could just build those things. You can never compete with that. The only place you could compete was like you have a fundamentally new technology where you were, right. So you combine all of them, boom! Like suddenly the people that will be investing in semiconductors and hard technologies, finding that there's not enough opportunities, or the opportunity threshold is much higher now. And then this emergence of these mobile apps, the internet apps, cloud apps, and then so why would you do that? So you do that for 10 years, institutional knowledge is completely gone. So initially it started off as a big area coming up, and then all the hard tech folks just kind of retired. All the new VCs were hired into these firms as associates and principals. They were all doing software. 10 years later, now I sit in some of these panels or dinners, and then they ask me, how come in deep tech, like, you get these revenues of 1 million 1 year, and then the next year is 30 million? How do you account for that? It's like,
That's the
yeah, you
nature.
get one design in, yeah, you can just say that you can do 30 million units, and then, yeah, that's how it goes. It's not like software where you're going from, even 5x growth, right? Whereas, like, suddenly you get one design when you go 30x or even 100x is possible. So the institutional knowledge is completely forgotten amongst the newer, younger circles as well, right? Like the associates and principals as well. So we need to start building that, right? So which what's happened in the last 5 6 years. Like now, more firms coming up and whatnot. But anyway, so that's the history of what happened and what's the missing gap and whatnot. But yeah, I'm very bullish because, like I said, the technology used to buy technology. Now verticals are buying technology. Other verticals are getting disrupted. So we are in a kind of a golden age of this core deep tech, hard tech, because we're seeing things around robotics and automation. We're seeing things around synthetic biology affecting a lot of the industrial applications. We are seeing the new generation of computing in quantum computing. We are seeing the core AI stuff that's solving a lot of the classification generation problems that was never possible. So we are kind of in the golden age of new technology solving problems now. And I'm sure once some of these infrastructure gets built, you're going to see a variety of application layer companies. But anyway, so I think we'll just keep doing this cycle of new technology which provides the infrastructure, and then application companies that come and take use of the infrastructure and then build interesting applications for consumers.
I want to talk about one of your portfolio companies, which is PsiQuantum. And recently, Quantum had some breakthroughs from Google, but I think you invested in, way early before anything about quantum was in the narrative. Talk a little bit about what was the impact on PsiQuantum. What is the company really doing? Because I think they'll say practical applications that they're trying to do. I think that's sort of like undercovered right now. Is like there's a lot of narrative around quantum, but no one really knows what the outcome or the use cases that are going to come about. So if you can shine light on that, that would be good.
Broadly, like, look, we are basically hitting the limits of computing because we've already gone to like 1 nanometer, 2 nanometer type of semiconductor chips. There's no more things to really pack, right? So, and then our computing needs are not going away. We need more computing and things like that, right? So we definitely need to figure out different form of computing architecture which doesn't have the same stuff. So quantum provides the best alternative at this point, right? So even though it may seem like, hey, are you going to put a quantum computing chip in your desktop? Maybe not, right? But so if you look through only that lens, yeah, it might seem like, oh, it's not there. There's no practical application, but that's not really true. Today, if you really want to push the edge of computing beyond what we can do through using our current semiconductor technologies, the best option for us right now in front of us is quantum, right? But the basics of quantum is that it draws insight from quantum mechanics, where anything can be in two states at one time, right? Multiple states at one time. But if you go back to any of our computing, current computing, digital computing, right? It goes to the same thing. It's either a zero or a one, right? Like we might do it in different forms, but it goes back to the same thing. It's a zero or a one. With quantum mechanics now, it can be a zero and or a one. It can same bit can take multiple states, right? That suddenly has exponential qualities to it, especially if you put a bunch of them together, right? Like if you think about 8 bits, suddenly it can stay in 2 to the power 8 states at one time, right? So and then if you're able to then use that ability to actually store that kind of data and use that kind of exponential thing, and then you can actually do some arithmetic on top of that. Now you can solve some complex exponential problems which should take much, much harder to solve using conventional computers. That's what quantum computers do, right? It's not for control logic, right? Like, yeah, if you want to do if then else stuff, yeah, your current digital chip can do that, right? It's not for even some of the very regular computing stuff. Yeah, our matrix multiplication, yeah, maybe some of this our current computing will do. But there are a bunch of problems that are exponential in nature, which even today the best computers cannot solve over 1,000 years, right? So that a quantum computer could solve very quickly, right? So the first applications are all things that require these things. So you think about drug discovery. The reason we have to do actual trials is that we cannot simulate the whole interactions of in your body or with other molecules in a computer, because it becomes an exponential problem, right? But with the quantum computer, we could get most of that simulation done, right? Like, so which basically means you still may not be able to completely simulate because everybody is different, every people are different and whatnot. But you can get to the point where a lot of that can be understood from a computational perspective, whether this particular molecule is going to work or not, this particular drug is going to work or not. So which basically means we could basically get a drug to market much faster. We don't have to probably waste on 7, 10. At least we can go from instead of 100 molecules that we are spending on, we probably need to do like 4 or 5. That has like financial impact, that has timeliness impact and stuff like that, right? So the pharma application is computational biology application is a big thing. Same thing on the computational chemistry thing. Oh, if you want to figure out what compound to use, well, how does it interact with others, and then what is the impact of that? Suddenly, it's not computable. It's not you cannot compute it, right? So the first ones are all going to be this computational chemistry stuff, computational biology. There are a bunch of classes of problems that can be solved by quantum computer, or you can get closer to that. Those are going to be and those all have big, big impacts on business, industries, and humanity, right? So we're going to go do that. Right? Before saying that, hey, instead of my laptop, is it going to be a quantum computer? Well, that may take a while, right? But I think solving that is going to be the first order of things, and which we are not far away. I think like the way it works is like we need to have enough number of qubits, which is the quantum bits that it can be that can be put together, and then it has to be remain in the quantum state for enough time so that we can do a complex calculation. So that we're making progress, right? So of course, Google announced with 100 plus qubits and things like that. They're able to solve a problem that is kind of reasonably unsolvable using a traditional computer. And we invested in PsiQuantum because we believe that they have the right architecture to go to like a million qubits or tens of hundreds of thousands of qubits, so you can actually solve a really, really complex, useful problem and then solve that. Right. So and they're using photonics based stuff, so it has some interesting, advantages over an electron or particle based stuff. Anyway, so that's why we did. But just stepping back, if you think about like 40, 50, 60, 70 years ago, computing was there. Yeah, we didn't have a personal computer, but computing was there. Computers were used for a bunch of different things. So quantum computer is going to go through the same stuff. It's going to start there. It's going to go start in a server, solving some big problems for enterprises or government and whatnot, and then it'll come down. I don't know when it'll come down to a personal quantum computer, but I think in terms of the quantum computer going and solving some of these complex problems for industries, that's going to happen much sooner than people realize. Right? I think people always underestimate it until it happens. So I think we're like a few years away from slowly starting with significant breakthroughs in some of these problems using quantum computers.
Let me know if this is a fair sort of analogy or terminology that we can use. In computer science, we have NP problems, NP complete, and NP hard. And the way I always think about quantum is it will unlock all the NP hard problems that we could otherwise not formulate, an algorithm for in traditional data structures. Because, the complexity of running a problem and looking at all possible solutions. Because most of when it comes to NP hard problems, you have to go brute force or look at all possible combinations and come to a solution, and you don't have an intelligent algorithm that can, do it in a polynomial complexity time. So that's how I always think about quantum. Is that a fair
Yeah, it's a
way
fair.
to?
It's not going to solve all of them for
Yeah,
sure. It's not going to solve all of the NP problems, NP complete problems,
yeah,
but a subset of them it will solve. And then I think like as years go by, it's going to do a smaller subset. Then a next subset. There's like DARPA is even has put together like what sorts of stuff can be solved in what time frame and things like that. So you're going to do that in layers, but you're right? Like but those are the types of problems, subsets of those problems that you will start solving are getting closer to solutions. You're exactly right. Yeah.
and that's what leads to this whole mania of that. Okay, the current cryptography doesn't work, and Bitcoin might not work because when you can brute force something which is very complicated and then which
Yeah.
panic for 2 days and it's no longer any more panic. But what do you think about that?
Yes, some of those things could be broken, but there's also ways to fix that as well. You can figure out a way to do quantum resistant stuff, right? Like
Yeah.
in some ways it's like I see it as a Y2K problem of this century, right? Like
Mm.
sure, you could go fix it, right? Like it's more complex than the Y2K problem, obviously, but you could come up with quantum resistant encryption and stuff like that and whatnot, right? But yes, one of the side effects would be that some of the things that you relied on today, this cannot be done through computing. It's going to take thousands of years. Now, okay, I can solve it through that, right? So yeah, there's one of the byproducts of that. But I think when I think about it, when I think about it, it's like look, there are ways to make it resistant to that. So I think people are going to come up with that. So yeah.
What are other like promising either companies or technologies around quantum? Like, are they like companies that are doing quantum safe encryption? Are there other companies like PsiQuantum doing interesting stuff around, creating next versions of quantum computers, taking the cutting edge research?
Yeah, so right now a lot of the work is happening around creating a quantum computer itself, right? So there are different approaches. There is this superconducting approach, which is what Google and D-Wave, Rigetti have all used. There's the ion trap ways. There's Continuum, which is the Honeywell, the spin out a Honeywell company, and then IonQ are doing. There's neutral atoms approach. There is obviously the photonic approach. There's also a silicon based approach. So right now there's like different approaches to getting these things right. So that's where a lot of the stuff is happening because you need to have like a good quantum computer. Then you can do the next layers. But the problem is that there's like because it's a fundamentally different type of computer, right? So the middleware, the device driver, the way you will map an application into that, all of them are going to be fundamentally different, and there is opportunity to create value in every one of those steps, right? So there are companies doing all that. And then there's also interconnect stuff. Okay, now I build a good quantum computer. Okay, how am I going to interconnect to do a problem, right? Or what is the equivalent of a motherboard here, type of a thing, right? So there are interesting stuff there. There's also the quantum properties can be used for communication stuff as well, quantum communication stuff as well, right? And then obviously quantum encryption. There are photon sources. There are different areas that are that people are doing stuff. Interesting companies. In the U.S., University of Chicago, University of Illinois, Princeton, Santa Barbara, they're all driving a bunch of these things. Similar stuff happening in UK, Canada, Australia. So there's a lot of interesting areas that are coming up. But it's also, you have to note that I see it as a sense of where 1960s, 50s semiconductor was, which is like it is going from physics to engineering, right? Like it was like a lot of physics stuff is moving to engineering. We are exactly in that same regime in quantum. Like there's still a lot of quantum physics needs to be figured out what can be now built. So we are moving from physics into engineering. We're still in the early transition phases. So really a lot of the schools driving there are schools that have like researchers that are driving around like people who have like strong science background and physics background.
So we're almost at the end of our conversation. I ask all my best guests a couple of quick questions at the end. The first one is, what are you consuming, to stay updated, or just for fun, that's sort of influencing your thinking?
I think I do mostly science papers, technical papers, right? Because that's where a lot of the stuff that I'm interested in. Like seeing what those the things are. The archive.org from Cornell, where people are publishing their papers, print servers where people are publishing papers. So that's one of my standard stuff. And then I think recently with Notebook LLM, you can now make it into an interesting way to consume some of those content. There are other LLM ways to consume the interesting content. You can consume these things much faster, much. You can at scale as well. As I do that. Um, on the technology front, that's probably what I'm looking at, what I do. And then in terms of other areas, I'm always looking at which places are becoming starting to adopt technology faster, right? And that changes all the time, right? So today, when I was doing startups, even when I was doing early venture career, if you told them, hey, manufacturing and industrials as a good customer, are a company selling to those industries, we'll run away, we'll run faster, right? Like, okay, I don't want to find a company to sell into those things because they don't adopt technology and all this stuff. But today, if you go to some of these stuff, especially for robotics and automation, they are consuming like they're adopting technology like much faster than you would think. Right? So I'm looking for those type of stuff. So it typically shows up as some of them different things trying out, different things being built out and whatnot. So I'm constantly watching for that. What is the forcing function? What is driving some of these people and what are those things, right? So between technical stuff and then now there are different ways to consume that and watching for these type of stuff. And then I still keep myself updated by I have my own AI PC to work on some stuff and whatnot. Nothing useful, nonsense, but it keeps me going in terms of trying out a bunch of different things. Right?
What do you know about investing that you wish you know when you started your career?
It is not a monolith. Investing in a stock market is very different from investing in a Series C company versus investing in a seed company versus investing in a pre-seed spinning out from a thing. They're all different. And different ones have different levels of gut instinct versus data driven. Uh, yeah. So I would say those are the two things, right? Like, it's not a monolith, and then there are different skills required in different things. And then figure out where you are good at, right? Like, so I think I've come to the conclusion in the last maybe 10 years of my own introspection is that I'm more comfortable in this early stage, right? Because it also has the intuition and gut as well. Um, it's not just purely data driven, right? Like there is, so yeah. I think like when you're starting your career, that's the one you want to figure out. What comfort, what you're already more comfortable with, right? Are you comfortable with data? Are you comfortable with uh, you know processes? Or are you comfortable with instinct, technology and instinct, right? Like depending on that, you probably have to fall in different parts of the spectrum. Yeah, it's not a monolith. Yeah, it's not single type. Even within VC, there's like several different types now. Yeah.
Yeah, I think that's a good note to end the conversation. Thanks for coming on the show and sharing all the insights about what you're investing in deep tech. Yeah, thank you.
Yeah, and I enjoy the conversation, Nataraj. Yeah, a lot of interesting questions that I typically don't get. So it is fun.